Howdy folks, we're back and continuing on in 1.7. So we're looking at example 5 now. It's looking at the domain and range and how those can be affected under various transformations. So we're restricting the domain of f to be from -1 to 2, including -1 and 2. Likewise, the range is restricted to 0 to 3, including 0 and 3. So that's based off of the original function f. So now the question is what happens to those under various transformations? So if we have a 3 in front and we have a 1/4 on the inside next to the x, what happens? Well, so we have to kind of think about this a little bit. The 3 on the outside is going to be affecting the f. Remember, f is another way to say that's the y value. So the 3 is affecting the y values, but the 1/4 is only affecting the x's. So all we have to do, as long as we know that, then we just have to do those calculations, apply those calculations to the respective pieces. So the 1/4 should affect the domain, and the 3 should affect the range. Now again, we're not saying that this value of x maps to this value of y. We don't know that. We're just saying what happens to the overall domain and overall range. So let's see what happens. So this is what we had originally, and now what does that 1/4 do to it? So the domain should be, if we take 1/4 of -1, then obviously we're going to get -1/4. So again, we're just multiplying it. Multiply it times the 1. If we multiply 1/4 times 2, then that's going to be 2/4 or 1/2. Done. That's the changes to the domain. So for the range now, what's going to happen to that? So now we're going to use this 3 and multiply it by both of those. So 0 times 3 is still 0. 3 times 3 is 9. And that's it. So we can use that same logic on this next one. So this -2 out in front is affecting the f, the overall function, which is the y value. And the negative on the inside is affecting the value of x, which is our domain. So let's start with the domain. So we want to just negate the the values of the domain. So we want to negate the 1, the -1, which makes it +1, and then we want to negate the 2, which makes it -2. Now, is that our final answer? No, we can't have it in the wrong order. We got to have the negatives first and then the positives second. So we don't want to write it like that. We want to write it -2, 1. So there should be our domain, and now our range, remember, is affected by this -2. So 0 times -2 is 0. 3 times -2 is -6. But we got the same problem, right? So we can't write it like that. We have to flip them around. And that's it. That's the changes to the domain and range. So we can kind of see that the number out in front is going to affect what the height of the function is going to look like. But on the inside, it's going to affect the stretchiness this way, horizontally. And we're going to talk more about that in a minute. Maybe not in this video, though. All right, let's try one more, and then we'll get to the final type of transformations. So we have our parent function, which is the square root of x, and we have some different transformations, and they want the equation of those transformations. So let's start with our first one. And if we want to use g of x, we can. If you want to use y, that's fine too. But the big question is what's going on? What happened to the parent function to make it look like that? So hopefully you're saying it's a reflection in the y-axis. So because normally it goes off to the right, and now it's going off to the left. So if we want a reflection in the y, how do we do that? Where do we put that negative in this square root of x? If it's a reflection in the y, we want to affect that value of x. So we want to negate the value of x. So that would give us the square root of negative x. That's it. All right, what about this next one? What's going on here? Well, we can see we're going to the right 1 unit, but it's also going down instead of up. So it's a reflection in the x. Okay, so let's see. Right 1. Well, if we wanted to go to the right 1, we'd have to just subtract x, or subtract 1 off of the x. So we know we'd have to have x minus 1. But when we reflect it in the x, we have to negate the entire function. So that means we're going to have to throw a negative in front of it. All right, so reflection in the x, shift to the right. Now what about this last one? This one's a little trickier. We can see it's going to the right 2. It's below the x-axis. Normally it's above, so that means it's reflected in the x. But now it's not going off to the right, it's going off to the left. So that means there's also a reflection in the y. So this one's an interesting one. Well, if we wanted to go to the right 2, we know that we'd have to have an x minus 2. But if we want to reflect it in the x, we got to negate the whole function. So we wanted to put a negative out in front, but we also want to reflect it in the y. So that means we have to negate the value of x. So this whole thing, we have to consider our x. That's our input. So we want to negate that as well. Kind of hard to see it, but we have a negative parenthesis x minus 2 close. Now let's pretty this up a little bit. So the negative out in front, we can't make that any prettier. But we can get rid of these parentheses if we distribute that minus sign through. So we'd have a negative x plus 2, and we can go a step further and just switch it around. You know, so personally I would take any one of these forms because they're all equivalent. This one's obviously the most compact and prettiest, but any of those would be acceptable. So the one thing you don't want to do obviously is cancel out those negatives because that's a big no-no. So, okay, so let's stop here and then we'll pick up these non-rigid transformations in the last video. So stay tuned.